Okay, so today we'll deal with activity 5. Along with this activity, we'll combinedly deal with activity 6 also. Okay, so coming to the activity 5, it says a very important thing, that is neutralization reaction. Neutralization reaction, right? So if anyone asks you what is a neutralization reaction, now in this case the reaction, the word equation is very simple. When an acid that is mixed with a base, okay, listen, when an acid mixed with a base, what happens is we got a salt and water is formed, right? So when acid reacts with the base, what happens? We got a salt and water. Coming to the activity that had given us in activity 5 is very simple. So in this case, we'll take a test tube. Wonderful. In that test tube, we'll take some amount of HCl, okay, and we'll take one more. Okay, in this test tube, we'll take NaOH. Okay, now take an indicator, and that is nothing but a, let's say this is a phenolphthalein. What? Phenolphthalein. As we have discussed already, phenolphthalein is an indicator. When phenolphthalein drops were added to an acid, what happens is it turns to colorless. Okay, so there is no change in color. But when it is added to a base, what happens is it turns to pink or related to red color, pinkish red or pink color, right? So there may be changes happens when, now what happens is in one test tube, now we'll take a test tube now. Okay, in one test tube we'll take 2 ml, okay, 2 ml of HCl now, right? So in this test tube we have taken 2 ml of HCl. So in this we are going to add, what we are going to add? Phenolphthalein. Wonderful. How many drops? Drop by drop. 1 drop or 2 drops enough, right? When we added 1 or 2 drops, is there any change in color? No, because when phenolphthalein is added to acid, what happens is there is no change in color happens. Now here what we do was very little interesting thing, that is when this HCl is added with NaOH. Okay, so we are going to add drop by drop, which means 1, 2, up to more than 2 ml. What? Because we have taken HCl up to 2 ml, right? Now we are adding more than 2 ml of HCl to it. Now what happens is this solution now just turns into pink color. What had happened now? In the beginning there is no change in color, but after we had added more than 2 ml of NaOH, the overall thing gets turned to pink color. Why this happened? This because we just increase the basic nature in the solution by adding NaOH more than compared to the HCl. For suppose if you want to remove this pink color, just add HCl 1 ml more. Okay, if we add HCl 1 ml more, now what happens is that pink color just vanished off and it becomes a colorless again, right? If you want to do it, if you want to come back the pink color again, just add NaOH 1 more. Now what happens? Again the pink color appears, right? So this is a wonderful reaction to see while dealing with the activities. We'll deal with it, right? So coming to the reaction that has happened here is when acid reacts with the base, acid like HCl that reacts with the base like sodium hydroxide. Now what happens is there is a salt. The salt is sodium chloride formed and water, H2O, is liberated, right? So coming here, I had written a reaction, that is HCl, that is added to sodium hydroxide. Now what happens? We got a sodium chloride and water, right? So let's try to balance this side. This side hydrogens were 1. This side hydrogens were 2. Oh, okay. So let's put 2 here. So now hydrogens becomes 2. Hydrogens becomes 2. Wonderful. Now coming to here, chlorines 1. Here also chlorine 1. It's balanced. Sodium 1. sodium 1 balanced, oxygen 1, but oxygens were 1 here, no need to worry. Hydrogens were 1 and okay, overall this case H2O, sodium hydroxide here, 2HCl, 2H2O was. So if you remove this 2, okay, now 1 plus 1, 2, right? So it's balanced, right? So no need to add anything here, just simply make the equation to stay there, then you should easily balance the equation. Wonderful. So if anyone asks you what is a neutralization reaction, very simple thing, that when an acid reacts with the base, what happens? We got a salt and water gets obtained, right? Now tell me any neutralization reaction that is going to happen inside our body. Similarly, for suppose if you consider this is your stomach, right? This is your stomach, okay? Your stomach exactly at 12 o'clock or exactly at your meal time, okay, you're going to eat something, right? Okay, at that time it is going to liberate a juice, right? And that contains most dangerous acid, that is HCl, okay? HCl is liberated inside our stomach now. Now what happens is exactly at that time we are going to eat something, yes? Now this food particles get mixed with HCl, okay, and they are going to separate themselves, right? And then on what happens is decomposition happens and everything, digestion and everything goes on by using this HCl, okay? So the reaction that is going to happen here is very simple. What? Neutralization reaction. Is it happened? Not yet. But what happens is, for suppose if you missed your meal, now you tend to feel a little bit pain in your stomach, yes or no? The thing that is going to happen inside your stomach is this HCl is going to eat an inside layer of your stomach, protective layer, okay? It is going to eat it, and at that time you tend to get a little bit of a acidity problem, right? So at that time we are going to take a tablet, and that tablet is nothing but antacid tablet or Eno. You know about Eno, right? Okay, exactly at that time you consume Eno or antacid tablet. At that time what happens is this Eno or antacid tablet contains a basis, okay? The thing that is inside our stomach is HCl. When this HCl, that is nothing but an acid, that is going to react with the base that is present inside the antacid tablet. Now what happens is there is a salt and some amount of water gets generated inside our stomach, okay? Then that overall pain gets stabilized, right? So from this, the reaction that is going to happen inside our stomach is neutralization reaction, okay? So this was very important question, okay? Neutralization reaction, they might ask in the examination, okay? Write neutralization reaction, okay? So coming to the activity 6, okay? So this activity 6 deals with two cases here. What? Two cases. Now we have a metal oxide or non-metal oxide, metal oxide and non-metal oxide, right? So when this metal oxide like copper oxide, okay, so normally metal oxides have a behavior of a basic nature. Which nature? Basic nature. On the other hand, non-metal oxides have a nature of acidic nature. What? Acidic nature. So if you look at carefully, metal oxides have a basic nature and non-metal oxides have a acidic nature, right? So when this metal oxide gets reacted with the acid like HCl, now what happens? Yeah, now when this copper oxide that is present inside the test tube, okay, so if the copper oxide that is present inside the test tube, okay, when we add some amount of HCl to it, now what happens is after they both get mixed together, we got a solution that is bluish green, okay, we got a solution and that solution contains a bluish green that represents the formation of copper chloride, okay, and some amount of water gets generated, right? Now if you look at carefully, copper oxide is a base, wonderful, HCl is an acid, we got a salt, copper chloride is a salt, and H2O is water, right? this reaction looks like when acid reacts with the base, what happens? We got a salt and water. This thing we have learnt in activity 5, that is nothing but a neutralization reaction. Yes or no? Now, metal oxides acts as a basis, and when they react with acids, okay, they are going to act like a what? Okay, they are going to deal with the activity, okay, deal with the reaction, and that reaction is nothing but a neutralization reaction. Coming to the downward, when non-metal oxide, like it has the nature of a acidic nature, let's say carbon dioxide, okay, carbon dioxide, when it is in a dry form, solid state, okay, we'll call it as a dry ice now. Excess amount of pressure, due to high pressure, this carbon dioxide comes back to the gaseous state to the solid state. So that thing we'll call it as a dry ice. When it has a acidic nature, when this carbon dioxide gets added with base, okay, base like calcium hydroxide, that is nothing but a lime water, right? This reaction we have did yesterday. We got a salt, that is calcium carbonate, and some amount of water gets generated. Yes or no? Now if you look at it closely, again this carbon dioxide, that is that too in solid form, which means it has a acidic nature. So when this acid reacts with the calcium hydroxide, it has a base. When acid reacts with the base, we got a calcium carbonate, that is salt and water, right? So this is also one of the example for neutralization reaction. Yes or no? So from this activity 5 and activity 6, we easily say neutralization reaction is nothing but when an acid reacts with the base, what happens? We got a salt and water, okay. But suppose if they had given us neutralization reaction for 2 marks, okay, just simply write the definition and write one formula, okay, you will get 2 marks easily. But suppose they had given us 4 marks, okay, write the whole activity. Suppose they had given us for 8 marks, write this activity and put example 1 and write this, and I put example 2 and write this also, right? You will get easily 8 marks here. Clear? So based on the question formation, you need to increase the answer, okay. So in the next video, we are going to deal with activity 7. That was very important, okay. Don't miss that video also, okay. Wonderful.